Well, howdy, folks, and welcome back to a brand new start, a brand new semester. Can you feel it? It's wonderful. Anyway, we are going to be starting off our learning with Chapter 6. Getting those brain wheels going and turning, getting the old rust off of them. And we're going to start off rather light, okay? Just so kind of get the old dust and cobwebs out. Even though it's only a 2-week break, it can take a toll on you. Okay, so anyway, starting off with Chapter 6. Now, hopefully, everybody had a chance to come in and get the materials that I had printed out for you before today. But if you didn't, I will also be posting the materials on Classroom, so you don't have to worry. But you will have to print it out yourself. Anyway, for Section 1, we're going to be spending about 3 days on Section 1. 2, 3 or so. My plan book is updated, so you can check that out. We will be doing a quiz. I'll tell you what, let's just take a look at it now. We're going to be spending 3 days or so on Section 1, and then having a quiz to round out the week. So, again, we're going to be really quick discussions today and over the next few days this week. But what you want to have out today is a calculator, your formula sheet that you've been so diligent at keeping up on, and the notes if you have them. Again, it's going to be a real quick discussion today. We're going to do a handful of practice problems. So, yeah, it'll be a good time. Anyway, we are talking about momentum and impulse in this first section. Now, momentum is probably something you've heard of before. We use it in quite a variety of situations. Impulse, you may not be as familiar with it, but we have heard this term before. We heard this term back when we were talking about football and the NFL and physics, and they talked about kicking the football and that moment of impact from when the foot impacts that ball. In that moment, there is an impulse. It takes into consideration the amount of force and the amount of time that those two objects are in contact with each other. So we'll talk about that as we go on in this section. So in Section 1, we're going to compare the momentum of different moving objects, compare the momentum of the same object moving with different velocities, identify examples of change in the momentum of an object, and then describe changes in momentum in terms of force and time. There's your impulse right there. All right, so let's look at linear momentum right now, okay? Very simple, basic formula for us to do. Momentum is simply mass times velocity, so we're having a situation where objects are moving, okay? Now, momentum is represented by the symbol lowercase p, and it is a vector quantity. We get the hint that it's a vector quantity because we use velocity. So, very important. We need to include direction when we are calculating and solving for momentum. Anyway, the formula is P is equal to m times v, okay, which momentum equals mass times velocity, okay? So let us take a look at our first problem, getting right into it. Excuse me. So we have a pickup truck that has a mass of 2,250 kilograms, and it is traveling with a velocity of 25 meters per second to the east. Simply, we are asked to calculate what is the momentum of the truck. So we have our mass in kilograms, must be in kilograms, okay? We have our velocity, 25 meters per second to the east. We're solving for P, so we plug in our values into that formula we saw on the previous slide, and we get 5.6 times 10 to the fourth kilograms times meters per second to the east. Now, there really is no unit for kilograms, okay? It's typically going to have the dimensions of kilograms times meters per second, okay? So, again, no real unit to fit into that answer. So honestly, kids, that brings us to our additional sample problems. So if you would have your book out and turn to page 199 in your textbook. Going to lower this. We're going to do a handful of practice problems here, okay? So we're under practice A on page 199 towards the bottom. We're going to look at number 1, okay? Number 1, the question says, a deer with a mass of 146 kilograms is running head-on towards you with a speed of 17 meters per second. You are going north. Find the momentum of the deer. So again, we've got P, we've got M, we've got V. We're finding the momentum of the deer. We know that the mass of the deer is 146 kilograms, and we know that the velocity of the deer is 17 meters per second south. Since you are going north, the deer is traveling towards you, so it is traveling south. So P equals M times V, or 146 kilograms times 17 meters per second. Go ahead and calculate that out. Pause the video if you need to, but you will get an answer of 2.5 times 10 to the third kilograms times meters per second south. Now let's look at another example. Oftentimes, we're going to have to calculate scenarios that involve objects that are together. So if we look at number 2 is a 3-parter, okay? It says a 21 kilogram child on a 5.9 kilogram bike is riding with a velocity of 4.5 meters per second to the northwest. Part A asks us, what is the total momentum of the child and bike together? Part B asks us, what is the momentum of the child? And Part C asks us, what is the momentum of the bike? So, what do we know? We know that the mass of the child, I'm going to call that MC, is 21 kilograms. I know that the mass of the bike, MB, is 5.9 kilograms, and that they are traveling 4.5 meters per second northwest. Okay, so A asks us for the momentum of both the child and bike together. So P equals MV, and we're going to have to add MC plus MB and multiply that sum by velocity. So you're going to have, excuse me, if you round it, you're going to have, well, you don't have to round it, I guess. You're going to have 26.9 kilograms times velocity, 4.5 meters per second. Okay. And you're going to get something right around 1.2 times 10 to the second kilograms times meters per second northwest. You might get something different because in my original calculations, I rounded this to 27. Here, I didn't round it. I just put 26.9. So you might have a slightly different answer than me, but that's okay. Part B, we are to find just the momentum of the child. So we're going to do P is equal to 21 kilograms times 4.5 meters per second. And we're going to get 95 kilograms times meters per second northwest. I'm pretty sure it's 95 because my handwriting is kind of messy in this problem, but if it's not, let me know. And lastly, C, we're to find the momentum of the bike. So P is equal to 5.9 kilograms times 4.5 meters per second. You should get 27 kilograms times meters per second northwest. I'm going to pause here before we go into our final problem and just let you know that for your homework, you're going to be given your problem bank, and you are to do problems 1 through 10. Okay, again, 1 through 10 will be the homework questions that you are to do on problem bank A. And lastly, number 3, what velocity must a 1,210 kilogram car have in order to have the same momentum as the pickup truck in sample problem A? So, we're looking at a situation to where we don't know what the velocity of a certain a different object than the truck that we saw in our notes on sample problem A. Okay, so we have to a lot of times determine, how fast would an object have to be going, if it's lighter or heavier, depending on the situation, when it is compared to another object to have a similar momentum. Okay, so what we know is that this car has a mass of 1,210 kilograms. And we're going to be using the same momentum value that we did in our slides, in our first example. Okay, and we calculated that out to be 5.6 times 10 to the 4th kilograms times meters per second east. So we need to figure out how fast this car needs to be going to have the same momentum as the truck. And so we're going to have P equals M times V, but rearrange this to solve for V. We're going to get V is equal to momentum divided by mass. And so our momentum was 5.6 times 10 to the 4th kilograms times meters per second divided by 1,210 kilograms. And we're going to get an answer, you can pause this video if you need to, of 46 meters per second to the east. Again, we're still talking velocity, so we must still include the direction. And since our momentum that we used had the direction of east, we're going to continue that into our final answer. Okay. Yeah, I know I didn't put it into the formula. You don't need it. Okay. I had it written up here. No biggie. And that's it. So starting off pretty straightforward. Okay. So, make sure that you do problems 1 through 10 in your problem bank. The problem bank will be given to you in a separate post from the video and the other materials. So make sure that you get this done. Problem bank A will be due by probably by 11:59 the following day. So just make sure you check the due dates. Okay. Other than that, if you have any questions, feel free to give me a call. No, don't give me a call. Sorry. I feel like I'm leaving a voicemail on someone's cell phone. Give me an email. How about that? Or a message on Classroom. There you go. That works out great. Anyway, glad to hopefully see everybody here real soon. And I'm going to stop the video here. Have a good one, everybody.